Okay, get ready for a pretty mind-bending idea. What if your computer didn't just store files, but actually remembered how they were made? We're about to explore a concept that treats data not as this static, dead thing, but as something dynamic and alive. A whole new kind of computing where information literally has a history.
So this whole idea kicks off with a massive shift in thinking. Forever, computing has run on the bit, a simple on or off switch. It's just a single snapshot in time. But orbital computing throws that out and replaces it with something called an orbite, which is more like a dynamic oscillating wave. And this isn't just some techie upgrade, it's a huge conceptual leap. We're going from storing a single, static state to capturing an entire history within one tiny unit of information.
All right, so here's how we're going to tackle this. First, we'll dig into that foundational shift from a simple switch to a complex wave. Then we'll properly introduce the orbite itself. After that, we'll see how this gives information a memory, what happens when you build a whole network of them, and, how this all connects to the wild goal of actually replicating a mind. And then we'll wrap up by looking at what this could all mean for the future of data.
So, let's start right at the bottom, the very foundation of it all. To really get what orbital computing is about, you have to completely rethink how information is represented at its most basic level. I mean, we're not talking about making smaller, faster switches here. We're talking about throwing the switch out the window and using a totally new building block. So just imagine for a second. Every piece of data isn't a fixed point, but a vibration, a rhythm, a continuous flow. We're moving way beyond a simple 1 or a 0. Instead, the information is baked into the entire shape, the trajectory, and the phase of a wave as it moves and changes through time. Okay, so if the foundation is a wave, then what's the actual building block made of? Well, that brings us right to the core unit of this whole new model, the orbite. An orbite gets its meaning from two really interesting things. Its movement, its trajectory, and its context, its relationship to all the other orbites buzzing around it. This makes it inherently social and historical. A single orbite, all by itself, is basically meaningless. Its value only really pops into existence when it's part of a bigger, interconnected system.
So what does one of these things even look like? Well, structurally, it starts with a base unit of 4 interconnected parts. The easiest way to picture it is as a triangular pyramid. But this shape isn't just sitting there. Its unique geometry actually represents a specific waveform. And here is where it gets really wild. The connection between two of these pyramids can itself become a new node, a whole new pyramid. This creates what's called fractal depth, a pattern that just keeps repeating at every single scale, which means you could just keep zooming in forever, always finding more detail.
Now, this crazy structure leads to one of the most profound consequences of this whole idea. We're literally leaving behind the world of perfect sterile copies and entering a world where information carries its own past around with it.
Think about it, right? Every single copy of an ebook on the entire planet is exactly the same, down to the last bit. It's a perfect replication, for sure, but it's also totally lifeless. It has no character, no history of its own. But an old physical book that tells a story that goes way beyond just the text. As the source material puts it so well, it stores the musty smell, it stores the stains. All of that is information. It's a history of its own existence. And orbital computing is trying to give our digital files that same kind of richness, that same depth of experience.
What this means is that a finished document wouldn't just be the final words on the page. Embedded right inside of it would be its entire history. Every draft, every deleted sentence, every single moment of inspiration. You could, in theory, just rewind the file to see exactly how it came to be. The process becomes part of the product.
Okay, so we've got these individual orbites, each one carrying its own little history. Now what happens when you connect millions or billions of them into a massive network? Well, you get something that acts less like a traditional machine and, well, more like a living organism.
Yeah, this is no longer a static database where you just file things away. It's a dynamic lattice where every single node is aware of and influences every other node. So when one part of the system changes, these little ripples travel through the entire network, forcing it to constantly adapt and rebalance itself.
And a system like this has some absolutely incredible properties. It's fractal, right, with the same patterns repeating at every scale. It's always trying to find a balanced, oscillating state, an equilibrium, and here's the most counterintuitive part. Things we call noise or error in normal computers, here they're actually part of the computation. The system literally uses chaos to process information. It's this constantly churning, self-updating machine that behaves a whole lot like a living brain.
And that comparison to a brain, that's not just a nice analogy. It actually points to the ultimate ambition of this research, not just to build faster computers, but to create a completely new path toward artificial cognition. Right now, AI tries to simulate a mind by feeding it billions and billions of static snapshots of the world, pictures, texts, data points. It's an attempt to contain a mind inside a static framework. Orbital computing just flips that on its head. The goal here is to create a single, dynamic, holistic system from which a mind can emerge all on its own, naturally.
So in this model, the computer isn't just the silicon chips. The entire physical system, the actual flow of electricity, the thermal noise, everything becomes part of the computation. It's a truly holistic machine. Cutting the power wouldn't just be shutting it down. For the cognition it supports, it would be a lot like death.
This all brings us to the future. I mean, if a technology like this ever became a reality, it would completely change our relationship with information, starting with what it even means to save a file.
Saving a file would be less like making a photocopy and way more like taking a super high-resolution photograph of a flowing river. You're capturing a snapshot, sure, but it's a snapshot of something incredibly dynamic. And from that one snapshot, you could potentially reconstruct the river's flow both before and after that moment.
Just think about the practical power of that for a second. You could download a piece of music and not just listen to the final track, but explore the entire creative process that led to it. The file you save isn't just the destination, it's the entire map of the journey. So all of this leaves us with one final, absolutely massive question. We've seen how this technology could give information a history, a context, and something like a life of its own. Our own consciousness is built on memory and the continuous flow of our experiences. So what happens when our data starts to share those exact same properties? If information can remember, could it one day wake up